My name is Presley, and if you're in the right room, you're here because you're tired of doing repetitive tasks and you would love to automate that. So let's get started. I am a consultant for a company called Lean Techniques based out of Charlotte, North Carolina. I help people solve problems, technical, people, process related. I do a lot of conference speaking, so much so in fact that I am recognized from Microsoft as an MVP, which all that means is I love leveling up others in technology, whether that be .NET, JavaScript, TypeScript, as you'll see today. I already mentioned LT. I also do woodworking. I show this type of stuff because I like working in the open and when I make bad projects, because we all make mistakes and learn. So that was the very first workbench I ever made. It's awful, but you know what? I still use it today. That was my first attempt making a box joint with hand chisels. I'm still recovering from the scars on my left hand because I did not realize how sharp chisels could be. But enough about my fun mistakes and whatnot. Let's get into it. So, I don't know if you all realize this, but you don't have to take any notes. Everything you're going to see today is live. Slide deck, all the code. In fact, there's so much of this code live that if you were to clone the repo and follow up some of the setup, you could go run all these examples. So if you're really brave, like that gentleman was, you could just take a QR code and make a break for it. And then you've got an hour to come back. But if not, there we go. So you woke up this morning. You've got a mysterious letter to your address. You don't know what it is. You open it up. And unbeknownst to you, you have been asked for some help by the Justice League. Now, the Justice League, as we all know, are a bunch of superheroes who are busy doing all sorts of stuff, but they ran into a problem, and they need your help. So they whisk you away to the watchtower up in space to help them solve some gnarly automation tasks. Now, you might be thinking, well, that's what you have Cyborg for, right? He's really good with tech, but you know what? They're busy. They're saving people. So you show up, and you listen to their problem. And here's the problem that they've got. The Justice League is responsible for protecting multiple plants in the system. That sounds important, right? Kind of a big deal. Here's what's not so cool. Who's on call for which planets? They can't be everywhere all the time, right? Just like how engineers, not all the engineers can be available for all the systems, right? Somebody's on call. But who is it, right? What happens when Martian Manhunter thinks he's on call for Earth, but it's actually the Green Lantern, and they both show up, and they step on each other's toes? Or what about times where one of them goes on vacation forgetting they're on call, and then Wonder Woman has to clean up the mess like she always gets stuck doing? Who's responsible? This is the problem that we're trying to solve. The reason why this is such a big deal to me is that there's actually an effect called the bystander effect. And it's this idea that if a thing happens and there's a bunch of people, everyone assumes that someone else will do it. You don't want that for on-call. I especially don't want that happening for superheroes who are trying to save my planet. I'd much rather it be very clear. So we're going to build a little bit of that work. And because we are engineers, and I alluded to this earlier, we're lazy. There's this very well-known quote by Larry Wall, the person who created Perl, the programming language, is that there's 3 virtues of a developer: laziness, impatience, and hubris. Well, I'm definitely lazy, and I'm impatient because I wanted this yesterday. Hubris I'm still working on. We'll see how that goes. So what are we going to be building? We're actually going to be building an application and some automation that's going to actually tie into both PagerDuty and Slack. Because like any good superhero team, they use the best tools, right? So they're using PagerDuty to keep track of their on-call schedules, things like that, and they use Slack for communication. But with these systems in mind, and this is what we're going to integrate with, what are we going to do? So here's our architecture at a really high level. We're going to have a script. When it's ran, it's going to get data from the PagerDuty API. How many of y'all actually have experience with PagerDuty? Anyone? Excellent. Guess what? You need 0 experience to be able to follow this, so it's all cool. Once we get the data from PagerDuty, we're going to post a message to Slack using their webhook technology. How many of y'all have ever done Slack and webhooks? All right, sweet. How many of y'all have ever had to do that with the Slack app approach because they've kind of retired the old static web? Okay, cool. So if you have no experience with that, that's okay. This will work. So this is what we're going to be building. But I said we're going to be building a script. What's the language? Is it COBOL? Are we going to do this in COBOL? Is that a great language here? Kyle's saying yes, of course. I'm going to use TypeScript. I hear TypeScript is a really great language when interacting with web and interacting with APIs. I hear it's kind of good at that. So I've chosen the language. What about runtimes? Now, back in the day, it was really simple. You just used Node. But now there's a couple other options out there. We've got Dino and we've got Bun. They all have their pros and cons, right? Node, very well known, both its idiosyncrasies and some deficiencies it has. Dino and Bun are kind of the new kids on the block, and in some cases, they just hit like version 1 or version 2. Now, you can choose any one of these three, but in this talk, I'm going to actually focus on Dino, and here's why. It's got first-class TypeScript support. So if you've worked in a Node app, you know you've had to set up a tsconfig file, and then you had to do all this other setup, and then you had to put these other things. You don't have to do that with Dino. It just works out of the box. Documentation, solid. You need to look up how to do something, it's already there, you can leverage it. It has an interesting permission scheme, and I'm going to leave that deliciously vague for now, but you'll see why. I think that's kind of a cool concept in a minute. And then the last part is they support a lot of best practices out of the box. For example, how to handle environment variables. You don't have to install third-party packages, it just do. And I'll show you that a little bit later. So we've got Dino. That's going to be the runtime for the script. That's going to talk to PagerDuty and Slack. So let's start building a bit here. Now, we can create our script, and I don't know about you, but I don't want to run that script on my box all the time, because now I'm the failure point. Because you know what I like to do? I like to go on vacation. I like to sleep. I like to not think about or worry about work, right? So I need a way to make sure that this script is always running on a schedule. Does anybody have any suggestions on how we can make sure that this script runs on a schedule? Cron jobs. Okay, cool. So cron jobs will absolutely work, and most of the time people will set those up on their box, but that goes back. But I like where you're going. So I said schedule task or cron job, but what if I told you there's a piece of technology that each and every one of you use almost every day that can handle this for us? Oh, I was setting this up, but there. Continuous integration, CI jobs. GitHub Actions, for example, run on a schedule. Jenkins can run on a schedule. So you could have your job execute a script. What I really like about this approach is that this is using common tooling that any engineer in your teams are already familiar with, right? I'm not having to teach you how to set up this whole other thing or how to set up cron jobs and all the other stuff. Nope, just do. So we're going to be using CI. In this talk, you'll see me use GitHub Actions, but this approach would work with any other tooling. And you'll see that I've got now a CI server component in the upper left. So let's get started with Dino. You're going to want to put on your box. How do we do that? You can go to dino.org, and you can run any one of those scripts. It's pretty much either Choco install Dino, curl if you're feeling really frisky and not caring about security. You got some options there. But once you have it, you can spin up a Dino project pretty easily. Dino init. Not too terribly different than npm init. And what's nice is that once you call Dino init, it actually gives you, here's the commands you can run. It gives you a test runner out of the box, which means you don't have to set up Jest or vtest or any of those other test runners. So that's the best practice coming out of it. It automatically gives you a task for watching file changes, so you don't have to worry about setting up nodemon or some of that other stuff. It's just baked into the runtime, which is kind of neat. So we type in Dino init, we get some of these files, and we can actually run. So if I run like that Dino run main ts, here's the code I'd get. It gives you an export function called add, gives you two numbers, returns a number, and it does this really clever thing to make sure that the if check only runs if you're running from that file and not some other file. So if you've ever had to import a file and get some weird console logs, you kind of know what I'm talking about. Regardless, you run Dino run main ts, it'll print out add 2 + 3 = 5. So far you've got a Dino app running. Not too bad. We can go a little bit further. Let's go ahead and create our GitHub action. So I'm going to create a new folder called .github, workflows folder, YAML file, and I'm going to go ahead and create our on-call schedule. It's got 2 triggers. Workflow dispatch, that means I can run it manually. Second trigger is schedule, cron job. That means it's going to run at 8 a.m. UTC, Monday through Friday. Some people like to take days off, like me. Once we have those triggers defined, we have to define the job. So all of the Dino scripts will actually kind of follow this flow of where, all right, we're going to give it a name. It runs on a Ubuntu box because I don't feel like configuring a CI box. I don't know if you all like to. And our steps are relatively straightforward. We're going to check out some code. We're going to install Dino using GitHub action step, but you could have used the same script we did before. We're going to install whatever things that Dino needs, and then we're going to run the script using Dino run. Once you merge this into your repo, congratulations, you've got a Dino script running in your CI server. So you've got all the plumbing in place. Now here comes the fun part. We got to integrate with PagerDuty. But before we do that, we got to make sure there's some terminology. So you're going to hear me talk about an app. That's the thing that's running. Welcome to my TED Talk, right? So you have an escalation policy. An escalation policy in PagerDuty terminology at a very high level is, how do I notify people and when should I notify them that there's a problem? That's your how and when. And your schedule is, who in the world should I notify when something goes wrong? All three of these things go together. An app has an escalation policy. An escalation policy can have one or more schedules. But if you're looking for like just a very quick info dump how PagerDuty works, this is it. So now that we've got the terminology figured out, let's start doing some domain modeling. TypeScript. I hand wrote these types just based off the PagerDuty documentation. The docs are pretty good. Long story short, you've got a PD object that's kind of a shared type for lots of stuff. Escalation rule, which then flows into a policy, because a policy can have more than one rule. And with those types, we can then have the schedules. So we've got a rendered schedule entry, and then we've got a schedule. And that final schedule is the part we care about, because you can do overrides and all sorts of other fun stuff. But you don't really care about that right this second. Here's where you care about. We're going to write a function called getOnCallInformation. You give an escalation policy, and it's going to give you back a promise of a name and an email. So, I'm sorry, I thought I had some highlighting there, but not. So what we're going to do is we're going to use the PagerDuty API client. It's just a thin wrapper, so we're going to use that. And then we're just going to make a GET request to /escalation policies, get some of that data, and then we're going to get the schedule ID. Cool, we've got the schedule that the policy is using, but now we got to figure out the person. So what we do next is say, hey, for the schedules, I want you to get me the schedule for today. And once I have today's schedule, I want you to give me the on-calls user ID. There's a little bit of prop drilling I'm having to do to get that data, but this will work. The part that you care about is, now that I have this on-call user ID, I can get their name and their email. And that's what this last part is I'm just going to say, hey, PagerDuty, get users, here's the ID, and then I got the email and name. So if I did nothing else except for this code, I've gotten the hard part done, right? So much so, in fact, that if this was my main script for Dino, where I say, hey, escalation policy, ID goes there, let me get the on-call information, and if I were to log that to the screen, I will get this. This looks like a fun one, right? So remember I mentioned earlier that Dino has an interesting permission scheme? This is it. When I tried to run the script, it bombed, and it said, hey, Dino's trying to read something on your file system. Are you cool with that? Oh. This is what I find really fascinating compared to Node, right? When you're running an NPM package, that NPM package can do anything. There's no limits on it. There's no real restrictions. You had to lock down the box. Dino doesn't run that way. If you try to have your script do something and you didn't give it certain permissions, it'll prompt you like this and say, hey. So in this case, it's trying to read certain packages, and because I didn't give it the flag, allow read, I get this fun prompt. Now I can click allow, which is what I do here. And I mentioned about the permissions things, but it's really to anything outside resources. So things like reading and writing on your file system. Reading and writing environment variables. This is huge, right? Because you know as well as I do, sometimes you have environment variables that you don't want to bleed over in scripts. The fact that you can lock it down, not only through the ability to read the variables, but to specify which ones it can read from. It's that fine-grained if you wanted it to. Also making HTTP calls. You can't call out to the network unless you tell it specifically it can. So if you're in a very locked down environment or you're a little bit more security conscious, Dino's methodology here is really cool. The last one I forgot to put on here, but I will. It also can't do sub-processes. So you can't spin off a process to do some nefarious things. Dino won't let you do that. So I say Dino run, allow read. So this way now I can read all the node packages and stuff that I need for this. And now I get smacked in the wrist again, because now it's saying, hey, you're trying to go to api.pagerduty.com. You didn't tell me I could do that. So I go, all right, cool. I'm going to allow you to do that. So now I've got Dino run, allow read, allow net. Don't worry about the slashes. That's just so it could be on a multi-line so it could fit on the screen a little bit better. But once I do all of that, Batman's on call, right? You'll see later on it's a little bit intimidating to get a notification that Batman sent you a message. Yeah. But yeah, cool. So we run the code, and this is running locally on my box. Batman is currently on call. But there's a problem. That didn't send a message, and it didn't notify Batman. And it's running on my box. I don't want it to run on my box. So let's make this a little bit better. First step we're going to do, though, is API token. I showed this earlier where we're newing up the API client, we're passing an API token. But where's that coming from? Well, if I'm a new engineer, what I've probably done was I probably just hard-coded it to make sure it works. But that's a bad thing, because Robin would say we should check in our API tokens, and Batman says, nope, that's how we compromise our systems and our APIs. So instead of using hard-code API tokens, let's use .env files, right? Very common approach, especially from the Node NPM world. So what we can do using Dino is if I want an environment variable, dino.env.get. That's all I got to do. And it will either give me back a value or it will give me back undefined. But once I do that, I can get that variable. And then so I can update my code from earlier to say, hey, for the API token, I want you to read from an environment variable called PagerDuty API token. And this is awesome, but now the problem is I've now got to hard code the environment variable in my box. That's not cool, that's not sustainable, right? I really want to put that in an env file. So cool. Yep, that's me. So remember when I said that dino.env.get returns back an undefined if it can't find it? That bang is me telling TypeScript, hey, shut up, I know what I'm doing, it'll always be there. Otherwise, it would nag at me and say, hey, this value may not exist. You'll see how we will permanently fix that later on, though. Great call out, Jeff. So I created an env file to source my repo, PagerDuty API token escalation policy, and they're strings because I'm not going to give you my real tokens. That would be insecure. Now what I do is when I do my Dino run, I've got to pass in two more flags. Allow env to allow it to read from an environment file, or read environment variables. And then that --env file, the minute I pass that in, I'm letting Dino know, like, hey, read from the .env file from the root of the repo. You can read from that. For those of you who come from a Node background, you should probably already be familiar with that flag, because I think starting in Node 22, they started supporting that. But yeah, so that's how we can run Dino and do all of this stuff, and so far so good. Things working locally, we're not checking in our secrets because that would be bad. Now it's time to update our continuous integration. So what I'm going to do is I'm going to go to GitHub, click on Actions, and settings. On the left, there'll be Actions. I can add some new repository secrets. So that's what I've done there, is I've added two for escalation policy ID and PagerDuty API token. What that means is that now anytime that my CI script runs, I have access to those secrets. I have access to those values as part of the pipeline. So back in the GitHub action I showed you earlier, all I've got to do is just now pass them in as part of env in the bottom right. So that's how I can put my secrets in GitHub Actions, thread them through so they're actually environment variables that then Dino can run during execution. And some of you may be like, well, I don't like my variables being as part of GitHub Actions. Cool, you don't have to do it that way. You could do an Azure Key Vault, you could do Secret Store from AWS, whatever you would like. But at the end of the day, you're still using the same tooling that as a developer you're already familiar with. So that's why I really like this kind of setup. It's very mix and match as needed. But we do this, we run. Now granted, I ran this on a slightly different day, so we have a slightly different superhero on call. But in this case, my CI told me that Static Shock, who's one of my favorite DC characters, he's awesome. So he's currently on call now. Batman got off with it, right? That's cool, but we need to still post this to Slack, right? Because no one's getting notified. All I know is that GitHub can do the thing, or my GitHub action can. So I go to Slack, api.slack.com. I have to create a new app. I call mine Watchtower, and then we attach it to a Slack workspace. Then we go to webhooks. I hit the big button on to green, and then I get to pick a channel. So in this case, I'm going to pick like Hall of Justice, I believe is what I called it. And then I get this really fun thing that says, hey, the Watchtower is requesting permission, which is always really dope to see. And once I do that, I can write some more TypeScript code that does the following. So I get a webhook URL, and I can call fetch with a post. And when I do that, I get this really cool thing that'll show up in Slack. Watchtower posted a message called hello, y'all. And that's neat. So because our webhook is a protected information, we put it in our env file, and we'll now refer it. We'll update our CI pipeline in a minute. So this will still work, no problem. Jeff mentioned a really good point earlier about why did I use bang around environment variable. That can get really clunky, so what I usually do is I write a function called getEnvValue or throw. You give it a key, and it'll try to get it. And if it can't find it, it throws an exception. Because if you can't find the value, I can't process anyway, right? Because I don't either have the API token or webhook or whatever. And if I do have it, I'm going to return it. And now I can refactor my code to use this getEnvValue or throw. So if I were to run the code, it would all work just fine. Not too bad. Okay, so we can post a message to Slack. We got to set up mentions. We got to tag people. So to do that, we got to integrate with the Slack API a little bit more. In particular, there's a method that we care about called lookup by email. So when you call this API and you pass in an email, it'll give you back like this random 6-character thing. That is that specific person's token, like that, and that is unique to them. So once we have that, we can then use it like in get mention token, we can log it, and then we need to actually use it. So I update send message, because now it's not going to be hard code, we're going to pass in a value. And the part that you really care about is this. Less than sign at, because that's truly intuitive, mention token. But once we send that line of code, it actually added the superhero. It actually said like, hey, at Stack Shock's on call for the week. So now I've got a thing, I've now got a GitHub action that's running on every day or every week, whatever schedule I want, and it'll tag the superheroes on call. So now there's very clear accountability of who's responsible, so on and so forth. Stack Shock may not like it, but the rest of the league will. So I'm going to pause here for a minute. That may sound like this is kind of a made-up story. This was a legit problem I had to solve for a client. Like, so this is actual real stuff that's been dressed up a little bit in a DC story. The problem, though, especially even though if you've worked with Slack's messaging APIs, like Slack messages can be really complicated, right? There's clickable buttons. There's like call and response type stuff. I don't know about you, but I don't want to freehand write that JSON. That's a little bit, that can be tough. So what I did is I created a class called Message Builder. And so if you're familiar with the builder pattern from OO languages, it's a very similar concept. But essentially what we do is when you create it, you give it a title of what you want the message to be. And then you start giving us lines of text. And I'm just storing that into an array. And then at some point, you're going to tell me like, hey, I want to mention this person. Cool. Give me the placeholder text that you want to replace and the token we're mentioning with. And then this is kind of the magic, right? When you call the .build, it will create all of that JSON that Slack knows how to deal with. This is great because if you're wanting to call a Slack message, you don't have to worry about the JSON. Just tell me what you want, and I'll take care of the JSON for you. And this is really easy. Slack JSON, the more complicated it gets, the worse it gets to read. So I'm not going to bother you all with that. But what's cool now is I can update my send message to say, instead of giving me a string, give me a message builder, and then we'll just tell it to give me the JSON. And then to use it, we can do this cool thing right here, where we can say, hey, I'm going to get today's date and new message builder, on-call rotation for the day, this person's on call for the week, use the mention token. That's a lot easier to read because now I'm knowing what it's trying to do. And I can reuse that anywhere else in the code base. So that's kind of neat. And here's what it would look like. In this case, the rotation flipped over to Batman's, poor Batman's back on call, poor guy. So kind of neat. And I mentioned earlier we need to update our GitHub actions. So here's where I'm threading all the environment, secret variables in that we set up in the GitHub action from before. Now, one thing I'd like to pause here is we made this work for this one escalation policy, but you may have noticed that all of these things are parameters. So let's say that we want to support a second planet, or maybe we need to work with a different org. You could take this exact same logic, flip the params to be what you need, and another team could use it. And another team could use it, right? Let's say that you found a bug in your workflow and you want to make a tweak. Cool, update main.ts. You now update everyone else's pipelines at the same time. Really good for maintainability in that cell. So we've got one piece of automation down, but for those of you who are familiar with the DC universe, you know Batman's a planner, right? He's known as the world's best investigator. So one thing that's interesting about Batman is that he has a contingency plan for every member of the Justice League in case something goes wrong. Here's the thing, though, about documentation. It goes stale. And nothing's going to be more frustrating to Batman if when someone in the league goes rogue, he pulls up his contingency plan and realizes he hasn't reviewed it in the last 2 years. Right? That's going to be really annoying. So how do we keep track of that? Automation flow number 2. So Batman does engineering best practices. So what he does is he keeps all of his contingency plans and markdown files in a Git repo because he wants to be able to rev it and source it, right? So we've got to write some type of automation that can do the following. It's got to go to GitHub, clone the repo, and it's got to find all the markdown files in that directory. And then for each of those files, it's got to answer a couple of questions. Has this file ever been reviewed? If not, that's an issue. If it has been reviewed, but the date it has on there is invalid, right? Like maybe it's February 31st, or maybe the date was kumquats for some reason. It needs to be reviewed. And then our last criteria is, hey, has it been looked at in the last 3 months? Look, members of the league are always changing, especially if you read the comic books, so he's got to have something. If we find any markdown files with that fit any of those criteria, we got to add it to the review list. Once we have that list, we got to check. Do we have any files to review? Any plans? If there's no plans to review, then cool, we're going to send a message to Batman saying, hey, he's good, he doesn't have to review anything. Otherwise, we got to format the message and then send it. But all roads lead to Batman, so he'll eventually get a notification of some sort. Okay? First thing we got to do, we got to clone the repo. Here's how we can do that. Dino has this really cool thing called command, and it will spin up a subprocess. So this will literally say git clone, repo URL, and whatever folder you want to store it at. And then when we say command.output, that's what's going to cause it to kick off and do its thing. So cool, that's easy. We can clone the repo. Now we've got a little bit of a trickier problem. We got to get all the markdown files from that directory. So Dino has a really cool method called redir, which says if you give me a directory, I'm going to give you back all the entries. And once we have all those entries, we can start processing them. And if the entry itself is a directory, that means we've got a nested folder, we've got to recurse, right? So we've got to do the same logic again on now the new folder. And if it's not a folder, and if it's a file, and it's a file that ends in markdown, we're going to add it to our list. So at the end of the day, we'll end up having an array, which is the full file path of all the files that we're trying to look for, or all the markdown files that we may need to review. From there, I'm going to create a type called stale file, and stale file has 2 properties: a path, where's the file, and then why is it stale? Is it because it's missing a review date? Is it because it has an invalid date? Or is it just because it's stale? Each of those 3 things may imply something different, right? Maybe the review date's missing because it's a new plan and Batman hasn't had a chance to actually put the dates on it yet. Maybe it's an invalid date because someone may have manipulated the file and tried to trick them. Don't know. So with that data type in mind, we can write this new function called getStaleDocs. And what we're going to do is, apparently not advanced the way I was hoping to, but we're going to iterate through the files, get the content, get the last line of last reviewed on. If we have a file that doesn't have that line, cool. We know we need to review it, and the reason is because it doesn't have a date, so it's missing. All right, if we get to this part of the code, that means it did have a last reviewed online, so now we're going to get the date part by using the trim and the replace and all that fun stuff. You don't really care. The part you care about, though, is if the date we have isn't valid, then we need to add it to the list to be reviewed. And then last but not least, we need to get the current date, and if now is further ahead than months plus 3, then that means we're more than 3 months past. That means it's stale. We need to add it to the list. So that's our 3 criteria. And now here's our actual Dino script with everything from top to bottom. And let's see if I got this working. Yep. So we set up a temp directory. Here's where we're going to clone the repo and throw it in the temp directory, get the stale docs. Here's our logic, right? If there's no files to process, we'll send a message saying no stale docs to report. Otherwise, we're going to build up the message builder using reduce. So we're going to add a line that says, hey, this file needs to be updated for this reason. And then we're going to send that message. So here's what an example output could look like. This file needs to be reviewed because it's missing a date, or it hasn't been reviewed recently. And you actually get a full path, so Batman doesn't have to figure out like, oh crap, where did I store the Flash contingency plan at? Oh, it was in the root of that repo. So that's cool. So Batman's got his contingency plans. The league knows who's on call. One last piece of automation. The Flash is known to be a very jovial sort. Very carefree, loves building relationships. And what he's noticed is that the league has been focusing too much on fighting bad guys and not building up those relationships. And you know what the Flash really enjoys? A darn good cup of coffee. Loves having coffee chats with the league. So he's asked our help to build out something for him. Okay? So here's what we're going to do for our third workflow. We're going to write a script that contacts GitHub to get members of an org. It then takes that list of people, shuffles it up, and then pairs them up. And once we have those pairs, it's going to post it to a Slack channel. All right. Well, to make things work, I'm going to create two types, an org member, and that's really just to help me out because the type signature for GitHub's API calls are interesting. And then we have the GitHub members of org response. Here's our API. Here's where we call all the data. The parts that you really care about, though, is, sorry, I keep hitting that button wrong. The parts that you care about is the API, which is this org/org name of members. And then we get that response. And then once we get the response, we're going to map it to be our new shape. Because the only part we care about is that login info. The rest of it, we don't care. Fun fact, you cannot get a user's email address from the GitHub API, not consistently. Kyle, you're shaking your head no. That bit me in the butt for a long time. Unless, weirdly enough, you're working in an enterprise company that's using GitHub Enterprise, then it will work. Don't ask me how I know that one, though. So cool, I've got all the members. I got to shuffle them up, though. So I can do the order by thing, but I learned something new. There's a really cool algorithm that's well known for doing like well-ordered shuffling called Fisher-Yates. You can go read the Wikipedia page and parse through all of that, or you can just copy this. I know math random is probably not the best way of doing that, but math random is good enough for this. But essentially, this will give you a decently fine shuffle of pairs, or a shuffle of a list. And what's really cool is I don't care about the type. I can shuffle numbers, strings, fruits, doesn't matter, it'll work. So I've got a list of people, I've got them shuffled, but now I got to pair them up. So I'm going to create a new type called pairing, and it's got an A and a B, and then it's got an optional third member, because if you have an odd number of members, you can't pair them up equally, right? So you're going to have someone that's going to be more of a triple. So then once we have that type, we can create a function called create pairs, and then what we do here is we iterate through the list of pairs, -1 because we don't want to accidentally go out of bounds, push in the pair. So pairs will have all the evens, and then the last thing we got to do is we got to check to see if our original list of elements was odd. If it is, then we need to make the last pair a triple by setting the C property. But once we have that, we can then create a new function called shuffled pairs, which composes create pairs with shuffle. Now we've got that going. So if you give me a list of items, I'll give you back a pairing, a list of pairings. And then here's what our workflow looks like. We can get the member of the org, so in this case Justice League, create the shuffle pairs, and then we will build up our message where we'll say that this person's meeting with this person, and then if there's a third, then we'll mention them. And then we will send that message actually mentioning the channel, using that @channel. Run the file, because we have to do allow net, allow env, because net to read the APIs, env to get your environment variables, read to read the file system, env file. But once we do that, we get this. Right, got a coffee chat, nice bulleted list, and we mention the channel, so everyone is tagged. And if you work with the culture of the team, you can say whoever's the first person mentioned is the person who's responsible for scheduling that chat. Now, all of these things I've shown you may seem like really funny and like, oh, that's really cool. These are all real problems I had to solve at a company. So like this coffee chat thing, I was actually leading a fully remote team. And if you've ever led full remote teams, you know that there's no like real water cooler. So that means you have to be more proactive on scheduling time. This is the thing that I did, because at the time, Microsoft Teams, the system I was using, didn't actually have a random coffee bot. It didn't have any of those applications like Slack did. So I built it for that. That contingency plan bot I talked to you about, I did that to help us update our support documentation. Because I got tired and my team got tired of going to look at our support docs to go fix a problem and realize the docs were 6 months out of date. So they were useless. In fact, they were worse than useless, because if they, actually, I'd rather the docs had not been there, because then we would have had to start from scratch. Out-of-date docs are worse because it gives you a false sense of security. So all these are real things. And what I really loved about it is that after I built the first bot, other members of my team could build their own bots. Because just TypeScript, just GitHub Actions, it's the same tooling they're using today. So that's pretty cool stuff. Oh, and I forgot, we have to set up the CI here. So we set the CI and everything's working just fine. So we've built our 3 automations. The Justice League is super happy because we've solved some of their pain points. The Flash never did get back to us, though, for that coffee, which was kind of annoying of him, but that's okay. So we have done it. That does conclude this talk. So let me say thank you so much for having me out here this afternoon. If you've got questions, you're always more than welcome to hit me up on email at cameron@softwarementor.com. You can also follow me on Blue Sky, because that's where the tech community is migrating to, and that seems to be a pretty cool place. And if you found this to be interesting and you want to kind of know a little bit more about some of the stuff I do, you can always go to blogsoftwarementor.com/training, and that's where I have some of the other resources I use to train up other engineers. As mentioned before, all these things are live, so if you want to scan that QR code, if you trust me, you can find everything there. Otherwise, thank you all so much for your time today. I appreciate it. Yeah, what's up?
Question for you. So I saw with Dino, obviously, secure by default, you had to add
Yeah.
allow list. But honestly, I feel like I'm opening things up too much if I just say allow list, allow
Yeah.
list, allow list. What does that look like if you want to have it in that hybrid approach? Like, is there a config file? What does that look like?
When you say a hybrid approach, like if you wanted to lock it down specifically?
Yeah, like the allow read.
Yeah. So when you do allow read, it actually take in like what URL specifically.
Okay.
So you can actually pass that to CLI. Like, hey, I only want you to read from these URLs. And I don't know if you noticed it, but also lock it down to the port number. So you could say like, oh yeah, you can talk to this URL, but only on port 443. Okay. So you can get that fine grained with it. I actually use the environment variables say only read from these ones a lot, because most of the time, especially if you're in a corporate environment, there's like CA bundles, things like that you don't want to accidentally leak for those reasons.
But you still have to, even when you want to lock it down, you have to pass it in all through the CLI?
Yeah, to the best of my knowledge, there's not like a config file for it to read off of, but I could be wrong on that, because Dino 2 just came out not that long ago, and they've updated some stuff there. Great question, Kyle. All right.
Dino 2's release commercials were hilarious. Did you guys see Dino 2's release commercials?
I've not seen the release commercials, no. I do love the fact, though, that if you go to Dino's website, you can make your own Dino, like you can give it a top hat and like party hat and all that stuff. I thought that was kind of cool. It reminds me of like GitHub circa like 2014, 2016. Like it had that right amount of whimsy to it. I also didn't mention this, but the person/team over Dino was like the founder of Node. So he took a lot of the lessons that he learned from like Node, some of the good and some of the bad, and it's like, cool, let's not do that with Dino. So yeah, and the nice thing too is, right, none of this is mission critical code, right? So if you try Dino and you don't like it, cool, switch it out for Node, switch it out for Bun, switch it out for something else. All the stuff you saw here today is pretty interchangeable, right? As long as you can interact with APIs, you're in a good spot. Cool.